righty, let's take a look at what it says on the screen there. A little closer connection to how these guys are related as inverses, like that. So this is our exponential function, and we just want to write it in inverse form. So like the inverse lesson, we have similar steps. And we're going to use the definition. So we need to isolate the exponential. Similarly, if we started with a logarithm, you would isolate it and then use that definition. We haven't studied solving yet. That's the next lesson. Once you get into the solving and you understand it, after you isolate that special part, there are multiple techniques that can be applied. But I'm going to stick with the definition because we covered it in this lesson before, like that. Alrighty. So the first step is just switch out the X and Y like before. I prefer doing it at the beginning. I think I explained that difference in the book. Second step, like I said, this is the solve for X. So first part is that isolate, like that. And you can see I've written the rational part on the left of the equals two different ways. Does not matter. The first way, when you get done, you divide by the -2, and then the second one I've got there, I distributed the negative in the numerator, which changed the signs in the numerator. Either one is fine, does not matter. I prefer fewer minuses and negatives, personal preference, so that's why I did that. All right, so step continued. This is the part where I'm going to do the square, circle, triangle in the next lesson when we do the solving. There's a couple of different techniques that might be applicable, but this is the best. This is one of the techniques, like that. So exponential base, logarithmic base, the input, output switch their roles, and we are basically done. Just write it with the correct notation for an inverse. Now, there is an additional step you can do, which I've talked about since the beginning of the semester, double check. It does involve using the definition of the inverse, which is that composition, and which also are the inverse properties that we studied in this lesson. So you should be able to take the exponential and the logarithm and composite them forward, backwards, everything cancels but X. And that's how you know you did all the algebra steps correctly, like that. All right, next part of this question is answering these guys. Domain and range and asymptotes are always good to pay attention to. The intercepts and the points that I've got there are to help graph, like that. So wherever you want to start, you start there. So we started with an exponential function, which I think of as the parent, and then the logarithm is the inverse, but they're both parent functions and you can start with either one, like that. I then decided to do the asymptotes because they're fairly easy to recognize, that vertical shift for the function and the left-right shift for the inverse. In this case, the function was the exponential, the inverse was the logarithm, like that. And that helps me with the domain and range there. And the inverse relationship with that, opposite corner situation going on there. XY intercept exactly as before. Plug in or solve. So the y-intercept for the function, the exponential, is when x is 0. Super easy to evaluate, and that gets you the x-intercept for the inverse. Remember, from one to the other, the x and y in the point just switch, like that. So we'll pick the easy one to calculate, and then you've got the other corner there. All right, so x-intercept is when you set it equal to 0. So I probably plugged the 0 into the logarithm and evaluated rather than set equal to and solved. It's up to you how you do that, like that. And then just for graphing, I have this suggestion of pick a point on the left side, on the right side, and the X value that you choose is based on what you've got here. So basically, I need something negative and something, and I picked something kind of in between. I didn't do it fully there, but you want to pick an input value that gets you the output. You can actually put a dot on the graph. So if you make it too large, so I think, anyways, so again, I'm using the exponential to evaluate, and I picked one which is in between the intercepts, like that. No, I didn't. I picked, sorry, I can't count. So we got 0 and 0.6. I picked a negative on the left, and I picked a 1 greater than the 0.6 on the right. I did exactly what it said. I'm focused on the 2, and there's an X, and I'm looking at it, and it's confusing me. And then when you go to the inverse, you don't actually, have to calculate every single thing here. You do one, and then you use the inverse property to, you get that. And then, depending on whatever the question actually says, this one wanted both of them graphed. You might do one or the other, or none of the above. Um, just like we did with all the other graphs, start with the points, the asymptotes, connect everything to the best of your ability. I included the y equals x, so that this one is a pretty good one. You can see that mirror image about that diagonal line there. Alrighty, and there are some extra practice. I put them in the video along with, these are the same ones that are in the notes. And whether you start with the exponential or the logarithm, it's basically the same thing. Isolate that special part, and right now use the definition to switch it to the inverse form. Like I said, in the future, when you have more techniques on solving, you can choose alternative techniques, like that. And all done.